All right.
So one of the really cool things at Maker Faire UK is a real focus on DIYBIO to showcase it here. And it's really great to see this area kind of get a boost.
So here, what we want to do is to identify the species from which those meats come from. To do that, we actually hacked the protocol, scientific protocol, that is used to identify biodiversity in nature. But this process takes a long time, it's quite expensive, so we really had to look for a way so that it's very cheap and also very quick.
Showing a number of items, a lot of products that are available now and available in a not too distant future that have all been derived using the tools of synthetic biology. This kit right here, which is available from the University of Alberta in Canada, which allows you to manipulate the genome of bacteria. Genetic engineering kits for high schools.
First, you extract the DNA. And for that, we use very simple product you can find in any supermarket. Here is sodium hydroxide. You boil everything for 10 minutes. It will denaturate the protein and it will freeze the DNA. Then you have to neutralize the pH to make it neutral, it's better. We use some acids, hydrochloric acid. You can find also in supermarkets. Next step, centrifuging.
We've been representing Mad Labs doing cell biology, but we've had some very sort of lo-fi webcam microscopes, which is probably about the simplest hardware hack that you can possibly do. We've also been doing the tongue census, which is a census to work out the state of the nation's tongues. And seeing if we can find any correlations between different people's palates and the kind of foods they like.
So, I don't know if it's well visible, but basically we have some debris. All the debris from the cell are down the tube, and only the DNA is remaining in the solution. We take about 1 microliter, it's a very small amount, of this DNA solution that we put inside a very small tube here, it's a PCR tube. Inside is an enzyme, it's a DNA polymerase. The role of this enzyme is to copy DNA. It's the same enzyme that is replicating DNA in your body. Like the tricky point here is that the region that we're going to amplify has a different length for each species. Probably you can see some bands. Can you see them?
There's not much fluid.
Yeah. Can you see the bands? So each band, you have different position. So here, thanks to that, we can say that sample 2 is pork, for example. And that's right, it is pork. Using this protocol, it's only €3 per sample, knowing that you will pay 300 to a company. It takes only about 4 hours to process everything, when you will wait 3 days from a company to get the results. Yeah.
So here we've been making microbial portraits of people's lips or their kisses. But we use this technology that's culturing bacteria that's used every day in the science laboratory, but we're using it for a slightly different purpose. This is the kiss of one of the co-discoverers of the structure of DNA.
Yeah, everyone just sort of didn't worry about the hazards. It's the safest technology we know.
All the labs, biological labs, are either in academia or in private companies. In La Paillasse in Paris, the space where I found it, basically we built a large biological lab. It's a modern lab. I could do my PhD in this lab, but it's just open to everybody.
Creating this almost space that's somewhere between business and academia, that's like neutral to both.
Exactly. I mean, what's interesting about biotech is it's still strange and a little bit foreign to most people.
Right.
And so this is a great point of access.
Right.
If you come into our space, you might not have taken a bio class since high school, and suddenly you're doing it. Everything's hands-on, which is great.
Right.
We've seen robots, we've seen satellites, we've seen rocketry, you know, all the kind of stuff which is really cool and instantly attractive to kids and makes them want to do this. So personally, the thing I've really enjoyed here is seeing all the biohacking. It wasn't something I was much involved in, because obviously we're on the more electronic side. It's really crazy to see what people are doing with things like DNA sequences. It'd be really cool to see how we can integrate our electronics and our software to bring a kind of open side to the biohacking like we have with all the computers.
So I think what DIYBIO today and biohacking in general, biohacker space, biohackers I would say, their mission is really to bring biotechnology in the open source movement. You know, so saying that I'm making something but it belongs to everybody.
DIYBIO is probably the newest part of the whole thing. If it's done by people who are doing it because they love it, they're doing it for the betterment of themselves and those around them and the world. So who knows what will grow out of all of that? When people are doing what they love, great things happen.
It's time to make biology hackable.